here again with another exciting scientific experiment. Today we are going to be exploring bubbles, and we're going to be trying out 3 different bubble solutions to see which one can make the epic bubble, right? The biggest bubble, the strongest bubble, the prettiest bubble, the lightest bubble. Those are all different ways we can compare bubbles. So before I go into the scientific method, I just wanted to go over the supplies that you need for these experiments so that you can kind of gather that and then come back to the video. So the first thing that we're going to want to do is we're going to be wanting to make a bubble wand. Now, I made several different ones at different lengths, but as you can see, Melody, that one's a big one, so you can put that one down. These are just wooden dowels, and they have little eye hooks on the end that I screwed in. And then I cut a piece of string, and I looped it through the eye holes, and then I added a washer, something to weight that down. So that when we put the string in the solution, we come up, we pull it apart, that's where our bubble is going to form, right? Within the inside of the string. And then when we move it, the bubble will come off. So you want that weight on the string so that it separates the string out. Okay, this is the fancy version of making a giant bubble wand, but there were other ways that we could do it too. So I wanted to go ahead and show you that as well.
They're all tangled.
Oh, they're all tangled because we have lots of string here.
Yeah.
But I was trying to think outside the box, friends, and if you don't have a dowel at home or eye hooks, what I thought you could use is actually straws. So with this method, I just took a straw, a plastic straw, and I bent it over at the end and I stapled it. And that gave me a little loop, just like our eye hole on the other one. And then I added the string to it with the washer. Now this string is a little bit bigger because we were going to experiment with different size strings to see what kind of bubbles we could get from different size strings. But when I realized the straws were kind of flimsy, so I just taped some pencils to the straw to make them a little bit sturdier. So this was a creative way of using my resources that I had at home, just in case you don't have an eye hook and dowels. And then a third way that you can make an awesome epic bubble wand is just with straws and string.
It's pretty easy.
Yep, and with string you can also use yarn too, but you want it to be more of a cotton-based fiber versus a plastic-based fiber, okay? Because you want it to be able to absorb the water bubble solution. So we just literally fed the string through the straws here,
and it can be bendy, but
it's okay. And then tied the string together. So this is another way to make a giant bubble wand. All right. The other thing that we did was, because we're going to make a lot of bubble solution, we wanted to play with bubbles. So we went around and we searched through the house for different things that had holes in them. Because obviously that is where you can blow through and the bubbles can come through. So Melody's just kind of showing you different examples of things that we found around the house that you can use to make bubbles. So be creative that way, just for fun, for playing at the end. Okay. You will need, for that bubble wand making, you will need string, like I said, or yarn, cotton, not synthetic fiber. You might want to take a tape measure and actually measure out the length of the string to be a little more scientific with your sizes. Maybe try to make a couple of different wands that have different lengths of string so that we can compare the bubbles that we get from the different lengths of string. All right,
and
now
then we need 3 big containers.
Yep, so we're going to start making our solution now, friends. So go ahead and start running your faucet because we want it to be the hottest water that will come out of your faucet. So I'm going to have Melody do that while I explain what we're going to be doing. So you're going to have 3 containers. You want to label them. This one is going to be our controlled experiment. It's just going to be dish soap. This one is going to say honey on it. And our third one is going to say corn syrup. Okay. So, what we're going to need is, Dawn dish soap is the best, but if you don't have Dawn dish soap, whatever dish soap you have at home,
it's okay.
Use that. You know, we can always go with what we have, right? So we're going to need Dawn dish soap, as Melody showed. We're going to use honey and corn syrup. Now, this corn syrup is a heavy dark corn syrup. You can use a light corn syrup as well. I chose to use the dark corn syrup because I wanted to compare, because honey is also a dark sugar.
But if you use the light syrup, sometimes
but we're gonna add another 2/3 cup of dish soap to all of our containers. Okay. So if you wanted to just cut the recipe in half, you could use 2 cups of warm water and 1/3 cup of dish soap. All right. So we've added our dish soap. Now it's time.
I just saw a bottle.
Oh, so now it's time to actually, we're not going to add anything else to the controlled experiment. So it's just going to be warm water and dish soap.
Yeah.
The next one we're going to be adding is our honey. And to add our honey, we're going to add 1/3 cup of honey. So
we have a lot of honey, so we can make lots of these.
okay. So we're going to add 1/3 cup of honey.
Ooh. Oh, look, it's making green on the outside. That's cool.
Okay, and so for our can you hold this, Melody?
Yeah.
So that all that. So in comparing our solutions, we want to make sure that they're consistent throughout. So we just have 2/3 cup dish soap and 4 cups of water. In our honey, we added 4 cups of water, 2/3 cup dish soap, and 1/3 cup honey. Nope, just 1/3 cup honey. And now for our corn syrup, we added 4 cups of warm water, and we added 2/3 cup dish soap, and now we're gonna add 1/3 cup corn syrup. Melody, does the corn syrup look like the honey?
Yeah.
It kind of does, right?
Ooh, whoa, that's actually cool.
Okay, so can you hold that over that?
Yep.
The next thing that you're going to want to do, my friends, is we're going to be stirring those solutions. Now, when you go to stir these solutions, you're not going to stir them vigorously. You're just going to slowly back and forth. Nope. We don't want to create any bubbles, okay? So you're just going to slowly back and forth, nice and easy, mix these solutions up, okay? So our goal here is not to make bubbles right now, okay? Our goal is just to dissolve the dish soap and our sugary solution, okay?
Mom,
And also, would it be okay to use the same spoon in all of the different containers, Melody? What do you think? Nope, it's actually not, because you're changing the chemical properties. So because you use this one in the honey, right, we wouldn't want to use this one with the corn syrup because it has a different chemical property in it than this one. So here is another spoon, Melody. That one's pretty good. You can put that down and start slowly stirring.
Why is there already bubbles when I didn't even mix it?
I don't know.
Oh, this one's cool to stir.
Nice and slow. Again, friends, we have just our dish soap water solution. We have our dish soap, water, and honey solution. And our third one is our corn syrup, dish soap, and water solution. We're going to continue to slowly stir these solutions just to make sure that the honey and the corn syrup is all dissolved. And then we're going to set a timer. We're going to set a timer for 2 hours. And we're going to then take these outside and try out our bubble wands. So we will see you back in 2 hours. Hi friends, I realized with the excitement of making these epic bubbles that I didn't actually go through the scientific method with you in regards to our experiments. So I am going to put this into the front of the video when you see it so you won't even know, now that I've told you. Okay, so the purpose of our experiment is to see how bubbles are formed and to
examine different solutions that we make to see which ones make bigger and better bubbles. So here is a little bit of our research or our background. And this is all going to be in the Google Doc too, so you guys can read it too, but sometimes it's just nice to be read too. So here we go. Bubbles rely on surface tension to hold together. Water molecules like to cling to one another just like magnets line up with and attach to other magnets. They're attracted to each other. So water molecules line up with one another and form what's called hydrogen bonds. Those hydrogen bonds is creating the surface tension. So the surface tension allows the surface of water to act like an elastic membrane, stretching and holding a shape, kind of like a hair tie or a scrunchie. If you drop a small amount of water on a piece of wax paper, for example, you can see a great example of surface tension in action, because instead of splashing or flattening or the water just kind of going all over, it actually forms spherical little droplets on the paper. These droplets hold their shape because the water molecules are more attracted to themselves versus the wax paper. The strength of that attraction helps hold the water droplets together. So the surface tension of water is so strong, in fact, that it prevents us from blowing bubbles with just water. Okay, so how do bubbles form then? So by adding soap or a detergent, that is going to lower the water's surface tension, allowing bubbles to form. It does this by creating space between the water molecules. So it's going to be kind of like a layer. So you'll have a layer of soap and then a water molecule and then another layer of soap, kind of like sandwiches in between. So it does this by creating space between the water molecules, decreasing the strength of their attraction to one another. If you think again about magnets, when two magnets are really close together, the pull between them is much stronger, so it's hard to pull them apart, right? But as you slowly separate the magnets, it's decreasing the strength of the attraction, so it allows you to slowly separate them. It becomes easier to slowly separate them, right? So the same thing with a water molecule. So when we put the soap in between the water molecules, it's going to lower the surface tension and allowing a bubble to form, okay? So our third step in the scientific method is the hypothesis. We are going to propose that the dish soap, when we add it to the water, it's going to separate the water molecules so that air can become trapped inside. And when we add a sugary liquid to the dish soap, it will help reinforce those bonds, okay, with better bonds, which therefore we can achieve bigger and better bubbles. All right. We've already kind of gone through all of the steps that you guys need to take. So just keep watching this video and we'll be going through that. And then I wanted to kind of go over the results that we...
Okay, friends, so I am going to be attempting to make bubbles with just the Dawn dish soap solution, all right? We already made a video, but it didn't take or something, so here is take 2 with Dawn dish soap. So I'm going to stick the bubble wand in. I'm going to slowly come out of the solution. And I'm going to pull apart. Look at those bubbles. Maybe, Melody, maybe if I have you not maybe put it on the tripod and then you can just try to...
Yeah, that's actually better. Let's do that.
Whoa!
Oh.
Okay, are you on the camera, Mel?
Yes.
All right, we took the camera off the tripod so you guys can see these bubbles that are coming off. Now this is a really big string. I think that this string was the 9-foot string. Okay?
Better string.
And this is the 9-foot string.
Oh.
That we're using with the Dawn dish soap. Okay?
It's just the wind is helping us.
The wind is helping us a little bit. Yeah.
Oh,
all right.
that was cool.
Let's try the other wand.
We've already tried this in a previous video, but that didn't work.
So with the other wand, you got to get your hands down there and get your hands a little dirty.
Yes.
You got to get it in the Dawn dish soap. Now, you want to make sure that all of the surfaces are in there. Alright friends, I'm not having a lot of success with this, and I think it's because my fingers are the ones that are touching, but you can see.
Oh, you see that bit? Well,
if you do make a wand that's like this, I would make the string a lot shorter. Okay? Let's see if maybe
or if you have a
just,
bigger
like,
container and it's
a bigger
wider and
container.
stuff.
Let's just try to pull this up like this.
Oh, that's actually a good idea.
Okay.
It popped up.
Yeah.
I might.
This is definitely not as epic as the other one. All right, so let's stop this video and let's switch solutions.
Okay.
All right, friends, so bubble experimenting is a really good socially distancing activity. And Nick happens to be my neighbor, so on a day like this, we saw each other outside and I thought, he could come over and help us with one of our solutions. So he is just touching his own solution and his own wands. So we're being completely safe there, but we thought we'd mix it up with a little bit more scientists in this experiment. He's just gonna slowly mix up that corn syrup. You do a little faster than that, Nick, but just, we want to make sure that we're not creating a lot of bubbles, right? Yeah. Okay, all right. Put that to a side. And since the last one had a good success with the dowel wands, now this one is got just a 3-foot string inside it. So it's gonna be our smallest wand, our smallest string. Go ahead and dip it in. Get it all, you don't have to dip the sticks in, you just dip the string in, slowly come out of it, out of the solution. And then you're gonna pull the strings apart, or pull the sticks apart. Now, blow. Did it pop? All right, do it again. So if you wanna kind of angle yourself, Nick, so that the wind is kind of catching it, the wind is blowing that way a little bit. Yep, perfect. All right, try it again. Pull the sticks apart.
Oh,
All right, keep going.
Cool. And it popped again.
Keep going. It's a quick, just play around with it.
Oh,
It's popping.
that was cool.
All right, so far we haven't gotten a big epic bubble though, like the Dawn. All right, keep going.
Oh,
There was one.
there's one. They're probably gonna be little because it's
So Melody's saying that these bubbles are probably gonna be smaller because the string is smaller.
Ooh, yeah. And it's still going. It's still
Look
going.
at that. That's a
That is a
nice
perfect
sized bubble.
Oh, it popped.
Okay, keep
air,
going.
I think.
Let's keep going.
Ooh. Oh. That popped.
All right. You know, there's a lot of different things that are
Oh.
affecting
That was a really little.
our experiment right now, right?
Yep.
One, the wind.
Well, it's actually helping us too.
Yep. Well, it's helping us, but it's also hindering us too, because
One of you.
it's blowing, so we don't have to blow the bubbles, but it also it might be blowing too hard, which is breaking that surface tension, right, friends?
Yeah.
So that background knowledge that we learned about for science of bubbles is that surface tension. And the soap and hopefully the corn syrup is trying to separate the water molecules so that they can spread out, but yet still maintain that surface tension. So they're still connected, okay? All right, we're still working with this corn syrup solution. Oh, there was some good bubbles.
Oh, this one's still going.
Oh, look at that one is still going.
It is. Can you guys see it?
I am trying
It's
to
kind of hard to
try.
see. Oh,
trying
it's actually going up.
trying to follow it around.
Oh,
That
God.
was a great bubble, Nick. It
It's
hasn't
still-
even popped yet.
It'll stand- oh,
Oh, it finally did. Cool. All right, keep going.
that one's so high.
Keep going.
Oh, that's a big.
That was a really big one
I
too.
think that's the biggest one.
So, okay, so guys, just comparing the corn syrup versus just the Dawn dish soap. What do you think?
This one makes
All right,
pretty decent.
I think this one makes small ones.
make smaller ones. Okay.
Normally, when you were doing it, it always popped easier, but Nick has it like every time, but it just pops sometimes.
It's popping when it comes off. We're actually getting bubbles, big bubbles off of.
So
The
we're
corn
getting
syrup.
more bubbles than when
And look at how high they're flying.
yeah, they actually get to fly. Yours were popping.
Okay. All right, let's try the third solution with Melody. All right, friends. So, Melody, can you turn your bowl around so we can see that label on your bowl? Turn it so it's facing the camera. Perfect. So, Melody's bowl says honey. So, this is the solution that we did. Dawn dish soap with a 1/3 cup of honey and 4 cups of water. She's slowly stirring it up. We've waited 2 hours for the solution. This is our third experiment to see which solution can make the biggest epic bubbles ever. And we're trying out different kinds of wands. Okay, so Melody, let's give it a shot. Melody is going to be using the wand that we used with the straws taped to the pencils. So let's try that one out, Mel. Okay, we've got Mel's wand untangled, and I think she has a lot of string on hers too. I think she might have 6 feet of string, whereas I was working with the 9 feet of string. I also think, friends, I read somewhere where as you use your solution over and over again, one, your technique gets better, but two, the solution starts producing better bubbles. So we'll try that out as well. Whoa, that was a pretty big one. Now remember, Melody's using the honey with the dish soap. What do you guys think though? You think that we need to really add anything to the Dawn dish soap or just use Dawn dish soap? You think just using Dawn dish soap instead of adding the sugar? Okay. Little tiny bubbles? Okay. Wow, that was not a little tiny bubble, Melody. That was awesome. Whoa, that's pretty epic. Are you guys having fun doing this science experiment? Yeah. I think this is definitely one everybody needs to try. I think it's a safe one that you can invite a neighbor over to play 6 feet apart. Whoa! I don't know, Mel. I kind of think that we're gonna have to compare the video side by side. You're getting some really big bubbles like I was with the Dawn dish soap. Just the controlled experiment. So maybe honey is the right solution. Whoa! All right, step 5 in the scientific method is the data and the analysis. So, reflecting back on the experiments that we had, the results of the bubbles that we formed while just using regular dish soap were pretty good. We actually were able to form a lot of bubbles and large bubbles with just regular Dawn dish soap as our controlled experiment. The solution that had the corn syrup didn't actually produce as well as the Dawn dish soap. We were able to form bubbles, but they were less frequent and they tended to burst right off of the wand. So I would say that just regular Dawn dish soap is actually better than just using corn syrup with Dawn dish soap. And then our third solution, though, which really was amazing, was the solution with honey. And we were able to make and create really big, epic bubbles with our honey solution. So I would say overall for our experiment that the honey solution was the best bubble making solution that we tested. And another thing that we kind of tested was like the different size string for our bubble ones, and we learned that the smaller the string is, the smaller the bubble, but there comes a point where the string actually becomes too big and it's hard to form a bubble. You'll have a bubble coming off of the string, but it won't actually like release from the string and close up and form an actual spherical bubble. So happy medium, we discovered that the 6-foot string on our bubble wand was the perfect size. And then lastly, on our scientific method is step number 6, which is our conclusion. And so I wanted to just kind of go over, restate the facts that we learned. So we know that bubbles hold their shape as a result of surface tension. In fact, the bubble solution mixture that makes up a bubble's surface is composed of 3 very thin layers: soap, water, and then another layer of soap. This is called a soap film. The surface tension of the water layer is what holds the bubble together. Therefore, when the water between the soap layers evaporates, the bubble pops. To make bigger and stronger bubbles, we needed to thicken the walls of the soap to prevent the water from evaporating. To do this, we added the honey or the corn syrup, and they are to help thicken the soap walls so that it holds the bubble together, so that we can create stronger, bigger, and longer lasting bubbles. At a certain point, however, bubbles get too big to hold together. Larger bubbles have larger surface areas, which means more places for external forces such as air pressure and gravity to have an effect. In addition, the larger bubbles that have their own weight to support. Imagine building a tunnel with Lego, and you make a very long tunnel with a small diameter, and if you try to make a tunnel that an adult could walk through, however, it's going to be harder to support because adults are bigger, right? So this is similar to what happened with the bigger size twine. So the body of the bubble is larger, but it's more fragile. That's why it was hard to create an enclosed bubble. So friends, I hope that you get outside and you have fun with these bubbles and you enjoy science. See you next time.